An oil spill was a major story of 2010, and there was a lot of misinformation floating around in the weeks after the spill. It was researchers, though, from USF's College of Marine Sciences who were thrust onto the worldwide stage when they discovered the real impact of the spill. And they have lots of other research, of course, but this was really the one that put you on the map. Joining us today, Dr. Jacqueline Dixon is Dean of the University of South Florida's College of Marine Sciences, and Dr. Stephen Murawski, PhD, fisheries biologist and marine ecologist. Welcome. It's good to be in your presence. Because, you know, you really broke the story on this oil spill, the true impact that was going on in the Gulf of Mexico. Was there kind of an aha moment when this happened, when somebody said, you know what, we think this is different than what's being reported? Do you know?
Well,
was
there was a whole series of information that started to come out when more and more independent researchers worked in the Gulf. And in combination with government scientists, I think we really revealed that there will be long-term impacts from this oil spill, and it's not just oil that's on the surface and going away. That, you know, the work that we've done has indicated that that oil remains. It remains in the deep sea, and it remains up in the marshes in Louisiana and other states, and so this is a long-term issue.
Well, what were you doing there? Were you dispatched? Did you, take a fleet of boats, or physically, what did this scene look like going out there to do this research?
Well, when there's a disaster, it helps to be prepared, and through generous funding from the state of Florida, the College of Marine Science had recently purchased a research vessel, the Weatherbird II, and had outfitted it with the latest and greatest technical equipment needed. So we were there, poised to respond quickly. And that's what's important. If you're going to respond, you've got to be ready,
Absolutely.
you've got to be prepared. So we had the ship. The University of South Florida Office of Research and Innovation actually ponied up $500,000 so that our scientists could get out there within the first week of the oil spill.
Wow.
So we had scientists ready who study the physical oceanography, responding with both the ship and with satellites of that initial question of where is the oil. And so through the use of satellites in the ship, they were able to give firsthand information to the first responders on where is the oil, and then predictions, where is it going to go?
Where is it going? And so then you were fielding calls, I'm sure, from all over the world, media wanting to talk to the researchers who'd really found the real story out there.
And then the question of most oil spills are a two-dimensional problem. It's a ship has a leak, there's oil on the surface, and so NOAA was utilizing standard two-dimensional physical oceanographic models of what's happening at the surface. This was a three-dimensional. This was an eruption.
The
of
USF
oil
researchers are out there leading
That's
the way.
Right. And so the USF researchers were ready with three-dimensional models of how the water in the Gulf is moving, not only on the surface, but throughout the water column. And that's what was required, those models, to be able to go out and look for oil and gas that was ponding, if you will, forming these subsurface plumes. And so, given the information from the models, then being guided with that to go out and find these subsurface plumes.
Wow. Now, the research is ongoing and continues in terms of what you're seeing in the impact on ocean life. I've read you've discovered ulcers on fish and rotting parts, and what are you finding is going on years after this has happened?
Well, in the winter of 2010, 2011, there were lots of reports from our commercial fishing industry of fish turning up with odd diseases. So we mounted a survey effort last summer to see just, in fact, how many of those fish actually had some issue in terms of diseases. And so we did a large-scale survey from the Florida Keys all the way up through Louisiana, and then we've repeated parts of that survey this year. And what we found was that the incidence of skin lesions and ulcers was higher in the area that the oil spill happened, as opposed to the relatively pristine Florida shelf. Now, what that means for the fish populations is still very active in terms of our investigations, and we have a large-scale grant from the Gulf of Mexico Research Initiative to study these problems in more detail.
And you're involved in the Council for Exploration of the Seas, And so you really have kind of a knowledge of how the ecosystem globally is all connected when you have something like this happen.
Well, that's right. Gulf of Mexico is not unique in the sense that these problems are shared elsewhere in the world. You probably know that we're exploring deeper and deeper in terms of production of oil in very deep waters. We've got issues off of places like Brazil, off of Africa and other places. And so people are using the Gulf of Mexico as kind of a model for how we are prepared for deep water blowouts, because they've continued even past the Deepwater Horizon effort. And the things that we've discovered and the things that we've learned are actually being applied throughout the world, not only by the oil companies in terms of how to mitigate this, but scientific researchers in other places of the world.
So in Frank's interview a few minutes ago, they were talking about so much of our seafood coming from overseas and foreign countries. Is some of your research focused on fisheries and overfishing and the fish supply that comes to the consumer?
We have a program, a Marine Resource Assessment Program, and Dr. Murawski is very involved in that, so I'll let him.
Well, as was mentioned before, so much of our seafood in the United States and the Gulf of Mexico actually is imported. Well, number one, we need to basically participate in, improving the supply, which by and large means improving the aquaculture contribution,
yes,
because wild populations are pretty much maxed out in terms of what they're going to produce. That being said, we also have to abide by the law and conserve and protect the wild populations and rebuild them to the extent we can. And part of our studies at the university are actually to come up with new methods to rapidly diagnose how many fish there are and supply information to managers so that they can manage to the maximum sustainable yield for the wild populations that exist.
So if the natural environments are pretty much maxed out, then we're looking at creating artificial environments?
Well, the Gulf of Mexico has many
cultivate?
artificial environments, artificial reefs and other things that recreational fishermen are so in tune with. One of the things that we need to emphasize is that it's not only about the commercial sales of fish products, but recreational fishing is huge business in Florida. Florida accounts for 40% of recreational fishing in the United States, and the west coast of Florida has a $9 billion a year recreational fishery.
Really?
So it's enormously important that we supply good information for the management of those fisheries.
What a huge economic impact on our area.
It's an enormous economic impact.
Dean Dixon, I know we've talked about the oil spill because that really brought you to national prominence, your group there, but you do other amazing research projects. When I was doing some research, the Greenland ice sheet melting,
That's
taking
right.
a look at that?
One of our faculty, Professor Don Chambers, utilizes a satellite called GRACE to look at gravity changes, which is how the mass is changing on the surface of the Earth. And he's been studying, using this satellite, the reduction in volume, rapid acceleration of mass loss of the Greenland ice sheet. And so we are a college that studies the global ocean, and if we're going to understand the impact to Florida on changing sea level and changing climate, we've really got to be looking at the poles as well as the Gulf of Mexico. And
Does it appear that that shrinking mass might affect the state of Florida at some point?
The biggest unknown in the projections of sea level rise in the next 100 years is how quickly the Greenland ice sheet will melt. And if the Greenland ice sheet melted today, sea level would rise 17 feet. That will affect Florida.
17, if it melted today, it would rise 17 feet.
Now, things are changing.
Well, we'd be underwater right here.
Things are changing rapidly in Greenland, and it's going to take careful monitoring over the next decade through satellites, through ships, through new technologies, through monitoring the velocity of the ice sheet, for looking at the oceanographic conditions, because it's really the glaciers that end over water, marine terminating glaciers, where the fastest changes are taking place. And so as the ocean is warming, the currents are taking more warm water up, and it's undercutting the glaciers and allowing them to flow more quickly. So
Wow.
if we want to know what's going to happen in Florida, we've got to be looking at the whole globe.
We sure do.
Not
There's
just
a huge
our local
connection.
environment.
Okay, so I read that your big interest is researching volcanoes.
That's right.
And
So-
you've been to the Galapagos and Iceland and Hawaii. What are you doing tromping around in volcanoes?
I love
I guess you
volcanoes.
do. I don't know why, but tell me.
My career turn-on moment was an oceanography class as an undergraduate, where I learned that the entire centers of the oceans are a zipper-like mountain range of volcanoes in the middle of every ocean basin. And I thought that was the coolest thing in the world, and that was my career.
I mean, that was your moment when
That
you
was my
said,
moment.
I want to
and
go
I
into
was
oceanic
out at sea
research.
on a research vessel when hydrothermal vents were discovered on the Juan de Fuca Ridge, and that was my career passion from then on. So oceanography, most people think about colleges or schools of oceanography only in terms of marine biology. That's what the public normally thinks. But we do marine geology, marine chemistry, looking at how the ocean chemistry is changing as the climate changes and the ocean is becoming more acidic. Physical oceanography, how water masses move mass and heat throughout the planet. Very critical for understanding how things are going to change. And who did I forget? Marine biology, marine chemistry, marine geology,
Wow.
ocean physics.
That's a broad spectrum.
So it is, really applying the basic disciplines to the study of the ocean.
Are you seeing an increase in interest among students saying, this is a really cool thing to study? Are you saying?
Oh, we have certainly gotten an increase in applications to the College of Marine Science since getting more attention after the Deepwater Horizon oil spill.
Really?
It has raised our visibility.
It's sort of like after the TV show CSI became popular, everybody wanted to be
Wants to be
investigators. Then
forensic.
after the Horizon oil spill, people said, hey, I want to go study oceanography.
Yeah.
We definitely have a upsurge in the interest level and the quality of the applicants, and so we're very selective in terms of the number of people that we can actually handle in the school versus the number of applicants, which sort of raises the bar a little bit. Because of the capacity that we have, we can only handle so many students. Very interested in the long-term effects of things like Deepwater Horizon, things like the hurricanes in the Gulf of Mexico and their impacts on the ocean. And I think people are more interested in the oceans as a societal issue as well. I mean, 85% of people in Florida live within 100 miles of the ocean. And so we are an ocean-dependent state. And I think people are starting to realize that it takes careful stewardship of the oceans for us to prosper and to have a sustainable impact on them. And so a lot of kids translate that into a career path.
And that stewardship is, I think a lot of people have heard of green jobs. And we're talking blue jobs. So
Blue jobs.
Blue jobs.
Blue for the ocean.
Yeah. So we are producing, we have a master's and PhD. Those are the degrees that we grant at the College of Marine Science. And we're, producing STEM practitioners.
STEM, boy, there's the big word, isn't it?
That are going to go out and get blue jobs. And it's an important part of the economic growth for the state of Florida.
Those blue jobs are actually reflected in something called the St. Petersburg Ocean Team. And we are in an alliance not only with the College of Marine Science and the university, but the other federal and state institutions that have something to do with the oceans. And so we're trying to groom graduates that would go into, for example, the National Marine Fisheries Service, which is in St. Petersburg, the U.S. Geological Survey, which is also there, the Florida Fish and Wildlife Institute, and others. And so we do have an economic cluster, if you will, there of blue jobs that we're trying to groom our graduates
So
for.
we have 30 faculty at the College of Marine Science, but there are over 1,200 scientists working in the marine science field in St. Petersburg.
It's amazing. Congratulations on your work with the oil spill and all the other things you're studying, and I look forward to your research making even more headlines. You're doing a wonderful job. Thank you so much.
Thank you, Ken.
Thank you so much. Coming up next, it's time for the SAFE Review at noon.